Concept 5 is evaluating expressions. We're going to evaluate algebraic expressions. And if you remember, algebraic expressions contains numbers and variables. So in the problems, you're going to see letters and numbers. In order to evaluate them, they have to tell us what the variable stands for. If we don't know what the variable stands for, we can't evaluate, we can only simplify. So for these particular problems, you're actually going to see off to the side that they tell you solve or evaluate this expression when x is 15. And that's them telling us what the variable represents so that we can plug it in. If they don't tell us what that means or what the x stands for, then I can't actually get an answer for this expression. I can just simplify it. So you will see off to the side for each of these. X is going to be 15 in this example. K is going to be a third. And then down here, it tells you what each variable represents in the expression as well. So let's look through some of these examples together. You do have to follow order of operations when you are evaluating expressions. So we're going to first start with a simple expression, x minus 9. They're telling us that x is equal to 15. So I'm going to substitute 15 in where I see the x. I'm going to rewrite it, so I have 15 minus 9, and then I just need to do the subtraction problem. 15 minus 9 is 6. So when I evaluated this expression, my answer is 6. Number 2, this says 6 times k. If you are not familiar with multiplication written this way, a coefficient in front of a variable is represented here as multiplication. So you need to understand that this is 6 times k. It's just understood that these two next to one another will make a multiplication problem. You don't actually have to put any multiplication in there when you write a variable and a number. Now, what's tricky about this is that when I go to substitute 1/3 in for k, I cannot do this because that looks like 6 and 1/3. I can't assume someone knows to multiply 6 times 1/3. So this is not okay. You cannot just plug that in and assume somebody knows to multiply. When I rewrite it, I have to show multiplication some way. There are different ways you can show multiplication. In this example, I've used parentheses to represent multiplication. If I wanted to, I could use a dot to represent multiplication. We do not want to use x because x is also a variable, and we don't want to confuse, is it multiplication or is it a variable? So we stay away from using x for multiplication when we start working with algebraic expressions. So here are two different ways I could write this. I could use parentheses to represent multiplying, or I could use the dot. All I have to do now is multiply straight across. And 6 times 1 is 6, and then I would multiply the denominator straight across. 1 times 3 is 3. So I actually have 6 over 3, and to simplify that, 6 divided by 3 is 2. My answer is 2. In the third example, you see several variables in the expression. I have a w, an x, and a y. It tells me what all three variables represent. So when I go to substitute them in, when I see w, I put a 6. When I see the x, I put a 5. And when I see the y, I substitute in the 3. In this particular one, they've put parentheses around each of the numbers. You would not have to do that. You could just write 6 minus 5 plus 3. I'm ready to follow order of operations. I have to subtract first because it comes first in the problem between a subtraction and addition. So 6 minus 5 is 1, and then I just have to add the 3. 1 plus 3 is 4. So when I evaluated this expression, my answer is 4. And the last example is x squared minus x. It tells me that x is 9. So wherever I see an x, I will substitute it in. I have to do that twice. I have to do an x, there's an x in that particular part of it and in that part. So I'm going to rewrite it as 9 squared minus 9. Following order of operations, I need to do the exponent first. 9 times 9 is 81. And then I bring down the minus 9, and I have subtraction left. 81 minus 9 is 72. So I evaluated to get the answer of 72. It's your turn. I want you to try these your turn problems yourself, and I want you to pause the video. Once you have done each problem, push play and see if your answers match mine. Check your answers with mine. If you have an incorrect answer, go back and compare my work to your work and see if you can find where your error might be. When you are evaluating expressions, you can do this with the real world too. So one particular example that comes to mind is degrees and Fahrenheit. There is a formula or an expression that we use to convert 1 degree or 1 degree Fahrenheit to degrees Celsius. So we're going to use this expression right here, 1.8 times C. So I'm assuming that this is multiplication because this number is written in front of this variable. So that's multiplication. So 1.8 times C plus 32. We'll take a degree or a Celsius and turn it into degree Fahrenheit. So I'm going to come over here and the problem says find the temperature in degree Fahrenheit that is equivalent to 30 degrees Celsius. So I know that my Celsius degrees is 30. So C is 30. So I'm going to come down here, and there's where the variable is showing that it's equal to 30. And now I'm going to plug it in. I'm going to say 1.8 times 30 plus 32. Again, remember you have to show some way that somebody understands that this is multiplication. And in this problem, we're using parentheses. And you notice up here in my work, I use parentheses almost every time to show multiplication. So now I have to do 1.8 times 30, and I get 54. Go ahead and rewrite the plus 32. And now I just have addition left. 54 plus 32 is 86. So what this expression is telling me is that 30 degrees Celsius is the same thing as 86 degrees Fahrenheit. Why don't you try one now? Here's a real-world example. See how many seconds are in 7 minutes. Pause the video and push play when you're ready to see the answer. The correct answer is 420 seconds in 7 minutes. Double check yours with mine. If you made a mistake, see if you can find your error.